The Elegoo Centauri Carbon is one of the most popular 3D printers on the market right now. It offered great print quality and specs at a pretty unbeatable price. But today we're going to be taking a look at the new version of the machine, the Centauri Carbon 2, to see if this printer is truly an improvement over the original, or if the added features are too little too late in such a rapidly changing market. The first step with any new 3D printer is to get it out of the box and set up. This Centauri Carbon 2 was very kindly sent over by Elegoo for me to test out early, but you know how we run things on this channel. I always just want to give you all a realistic look at what these machines are capable of creating. While I fight with getting this printer out of the box, I'm going to quickly run through some specs. The Centauri Carbon 2 is an enclosed Core XY style 3D printer. It has a build volume of 256 millimeters cubed, a max nozzle temp of 350 degrees Celsius, and a max bed temp of 110 degrees Celsius. It also has a built-in camera for monitoring and failure detection, as well as it is now multicolor capable with the new canvas system. So far, the entirety of this unboxing has just been removing packaging from the printer. Inside the printer chamber is the main shroud lid, which is packed full of different parts that we will be installing on this machine in a bit, but there's still even more foam and packaging to remove from the chamber of the printer. The build plate is one of Elegoo's dual-sided ones, which I'm a big fan of, but it has this sticker on the corner that I am still trying to get the residue off of my build plate to this day, so probably change the adhesive for that, Elegoo. Next, you'll need to locate this accessory bag, because within it is the little tool packet. There are 3 screws holding the print bed in place during shipping that need to be removed. They are pretty visibly labeled by these red arrow stickers. From there, I decided to move to the front of the machine to install the touchscreen. There are installation instructions on a sticker on the actual screen, but the process for this is just plugging in the ribbon cable and then slotting in the mounting points to the printer and then pressing down to lock it in place. And then of course remove the screen packaging. But now it's on to dealing with all of the parts that are packaged inside of that shroud lid. I wasn't entirely sure what was in here, so I started off by taking everything out of the various foam layers that are within this shroud. First layer were the various PTFE tubes and cables, the power cable, and then more things in relation to the canvas system and the spool holders. Underneath the first foam layer is the spool holders and the canvas module itself, but we're not going to be quite dealing with these yet. Because first up is installing the nozzle wiper into the back of the machine. Had to bust out my phone flashlight to show you this one, but this nozzle wiper slots into the back inside, but you're mostly going to be doing the work on the back of the printer and screwing it into place. You'll find the screws for this within that original accessory packet. There are 2 different screws within this packet, countersunk ones and button head ones. The button head ones are installed on the bottom and the countersunk ones are installed on the top screw holes. Moving from the back of the machine to the side, it's now time to start installing the canvas module. The mounting bracket as well as the module itself are both located in the foam insert that has all of the spool holders in, and you'll find all of the hardware needed to install everything in that small cardboard box. And all of the screws are in individually labeled packets. First up is installing the canvas mounting plate onto the side of the printer. The mounting plate screws are really long, but they mostly just slide into the screw holes on the frame of the machine and then you tighten them into place. Then it's on to attaching the module itself onto the mounting bracket. The filament hub gets attached to the top of the hot end using 2 screws. The screw holes are located on the back side of the hub. Next, it's time to attach the 4 PTFE tubes from the hub to the canvas module. It technically doesn't matter which PTFE tube runs from the hub to the canvas module, but being reasonably tidy with your cable or tube management is never a bad thing. There are also these connectors to add to help you keep the tubes in order and stop the tubes from flopping all over the place. Going back to the side of the machine, it's now time to start installing the spool holders. First is installing the 4 mounting plates onto the side of the printer. There are 2 screws per plate. From there, the spool holders just slot onto these mounting brackets by sliding them down into place. At this point, I did not realize that these spool holders were actually labeled with the slot numbers, and I somehow managed to install every single one of them wrong. So once I realized that, I obviously swapped them around so that they were all in the correct location. The last bit of setup step for the canvas is plugging in the cable from the canvas module to the back of the printer. The final thing to add to this machine is the shroud lid, which there's a lot of packaging to first remove. There's also this smaller section of the shroud that you slot into place on the side of the larger piece before then sitting on top of the machine. All that's left to do after that is plug in the power cable if you haven't already, and then you can turn the machine on to continue on with the setup process. Starts off with your fairly typical language and region settings, as well as Wi-Fi connection. It will also remind you to remove the 3 bed screws if you haven't already, and from there automatically start running through a fairly typical 3D printing calibration process. Checking that all of the fans and heating elements are working properly, vibration compensation, and auto bed leveling. Once it's run through all of those checks, you're done. There will most likely be new firmware available that you should install before continuing on trying to print anything. And after all of that, let's get some filament loaded and start printing. I'm going to start with some of Elegoo's RFID spools so that I can show you how the canvas works. Compatible spools have an RFID tag underneath where it's labeled RFID. You tap that to the canvas module, which will allow the printer to read what the filament is. In this case, orange PLA. From there, you select which slot the filament is installed in and confirm. And you'll just repeat that process multiple times until you have all of the filament loaded onto the machine. If you're using filament that doesn't have an RFID tag, you go into the filament settings menu, select the slot that the filament is installed on, and then manually input the type and color of the filament. I really wanted to start putting the canvas system to the test, so for this first print on the CC2, I decided to go with this Ecron model from Avatar. This thing has multiple filament color changes on nearly every single layer. It's also technically a flexi print, so print accuracy and cooling are going to be important so that all of the joints print properly and don't fuse together. This also gave me my first look at how the CC2 and Canvas handle filament changes and how long it takes to carry out those changes. This is sped up, by the way, but when the CC2 is ready to change filaments, it first moves itself to the front right corner of the machine to cut the current filament. It'll then move itself back to the nozzle wiper area where it will purge the current color and then load the next filament into the nozzle. This entire process takes about 1 minute and 30 seconds from when it first stops printing to the time it then resumes. It will vary a bit depending on what filament colors it's flipping between. If it's swapping between 2 very similar colors, it will most likely take less time as it's not needing to purge as much filament as if it was swapping between, say, white and black. Yeah, average of about 1.5 minutes, which is pretty spot on in terms of the color change times for machines of this type. And after almost 300 filament changes and 17 hours later, we have our finished Ecron print. Also a bit of assembly, but this thing turned out so phenomenal looking. It has so many points of articulation on top of all of these color changes, so this was honestly a very difficult print, but it is a fantastic looking end product. And thankfully it did look so good because it helped ease the fact that there was nearly 81 grams of filament flushed from all of those color changes. I was testing this printer during the week that the entire internet was losing its collective mind over the Pokemon Lego and the exclusive gym badge set that's basically paywalled, and I thought surely someone has made 3D printable gym badges, and of course they had. But these honestly made for a great test print project. The badges are all very colorful, so I was going to be doing a lot of filament changes. I also used a little trick that I don't get to do very often, and that is print by object as opposed to the standard print by layer. Basically, these badges were at most like 25-minute prints each, and they were all completely different colors. So I was getting a bit tired of constantly having to change print jobs and swap filament. But with print by object, I could put multiple gym badges on the build plate as long as they didn't go over the 4 different colors between them, and have the machine print them one part at a time so that there wasn't any unnecessary purge waste produced by placing them on the same build plate. It was also really helpful for printing all of the rainbow badge parts. This was the only one that was in separate pieces given just how many colors are involved in this thing. It basically uses all of the filament colors from all of the other badges. There's also a print in place case for the badges. So this is a hinge that prints, as the name would suggest, in place. Again, not a bad print test for checking tolerances and cooling since this hinge is going to need to bend. There is a little bit of assembly involved, mostly gluing the magnets in place for the badges to then attach to the case, but the end product is was so worth it. You could of course just choose to print the badges to use as magnets, but in a case like this, it makes for such a cool display piece. Now that we've made our way through a couple of fun projects, I figured it was about time to start using this printer for something useful and boring. No, but really, I use 3D printing all of the time for so many different applications, and a lot of those times it's for parts for things that improve my day-to-day or work life. The useful prints just don't necessarily make for very good or interesting test prints, since the shapes of them are often more simple and geometric. But I did need more of these inserts that I use for storing filament in these cereal containers. There are a lot of options with this file depending on what features you want the insert to have, like adding a hydrometer. I've just been printing the simple version for mine that has the silica gel container that you fill up. These work fantastic and they don't take very long to print, so I printed a couple of build plates worth of those. Another more useful print that I had on my list was this hair tie holder that looks like a Nessie. This is obviously quite a cute design, but I did genuinely need something like this to help me clean up my bathroom countertop. I actually printed two of these because the first print honestly didn't look too great. The overhang on the chin was pretty rough, and I hoped that with a few slicer tweaks I could get it looking better. The second was definitely better looking, still some room for improvement, but good enough for my bathroom. Next, I wanted to dive into something that I was honestly a little concerned about, and that was printing in ABS. Now this is technically an enclosed 3D printer, clearly, and normally even without active chamber heating, printing in more temperature sensitive materials like ABS isn't an issue on machines of this size. But unlike the majority of enclosed 3D printers, this one has a very large shroud on top, I guess we will call it. And I would say it almost doubles the enclosed space of this printer, and therefore doubles the enclosure space that this printer needs to try to passively heat and maintain a decent temperature in. The CC2 does have a smart grill that automatically closes when it knows it's printing filament like ABS to retain the heat, but I was still concerned, not gonna lie. I wasn't going to go easy on it though, so I decided to try printing one of these Sith statues in ABS. I scaled it up to be 200 millimeters tall, so nearly the entire build height. Generally, you'll start to see problems showing up on ABS pieces the further you get away from the bed because it's colder. It's 100 degrees Celsius or so at the build plate, but once you start printing further away from that, you are relying on the enclosure temperature to be stable enough and high enough for the ABS. I ended up using 105 degrees Celsius for the bed, which had the enclosure generally being at about 45 degrees Celsius. The highest reading I ever saw was 51 degrees, but pretty consistently, regardless of where the build plate was, it managed to maintain that 45 degrees. That is with it working within a 21 degrees Celsius room, just as a reference point, and this Sith statue actually turned out really fantastic looking. It looks like there was a bit of a support failure around the chin, but it doesn't seem to have affected the print at all. This is a great looking piece, especially out of ABS. As another more focused test for the ABS, I wanted to have the machine try printing something that would take up more of the build plate and have more possible shrink force. So I went with these filament rack legs. These would typically probably be parts that I'd choose to print with a brim attached. To be fair, most of the time I choose to print all of my ABS parts with brims just as an extra security measure. It's a little bit more plastic to ensure a perfect print every time, and I can always recycle it in ABS slurry later. This time, however, I decided to go without, just to see how the Centauri Carbon 2 would handle it. And there was unfortunately some lifting on some of the corners. Not so much that these pieces are unusable, but it is noticeable, and if you needed these to be very dimensionally accurate, then it would be a much bigger issue. You can also see a bit of VFA texture. I'm not entirely surprised by that, as frequently ABS's max volumetric settings slow print speeds down to the point of putting them within the speed range where VFAs would start to show up. But I would much rather a print with that slight wavy texture that shows up in certain light over a piece that's structurally unsound because it was printed too fast. So a hit and a bit of a miss. I would still say this machine is fully capable of handling ABS though, because with some settings modifications, these legs could have turned out fine without the slight corner warping. I was way more concerned that the Sith statue would be the issue, but that print turned out great. I still wanted to put a few more print hours on this machine, so next I decided decided it was entirely necessary for me to try printing a life-size Judy Hopps. I scaled up this file so that the final model will be 60 centimeters tall. This entire print is separated into single colored parts, so there's going to be quite a bit of assembly later. I also thought it could be fun to try out using fuzzy skin on the fur pieces. I painted on the fuzzy skin because there's quite a lot of areas that other pieces need to fit into, and having fuzzy skin all over was going to start affecting the fit between pieces, which we don't want. I didn't do any print by object this time around. All of the parts were much larger, and I had enough of each color that they were sometimes more than enough for one build plate's worth of pieces. The fuzzy skin for the fur pieces was looking fantastic. I'm glad I thought about trying this technique out, and you can see in the spots where there isn't fuzzy skin just how smooth these prints were turning out. But we still had a lot of build plates worth of pieces to get through. I separated the original model up by even more colors to try and be as close as possible to the animated Judy Hopps. In total, I believe I ended up using 11 different colors of filament for all of the parts. But once I made my way through all of my build plates worth of pieces, it was finally time to start assembling. Well, first there was all of the support material to remove, which thankfully all came off relatively easy and I wasn't having to fight it too much. To assemble everything together, I'm just using some super glue. All of the parts were various colors and finishes of PLA, like for instance, I decided that some silk purple might make the irises look really interesting and lifelike. I also used a couple of other metallic filaments for any of the silver and gold parts, but the majority of this was done in various colors of matte PLA since you don't really want a rabbit to be particularly shiny looking. I ended up reprinting the ears as a multicolor print. Typically there's an extra piece for the pink of the inner ear, but I thought it would look better if the pink was just part of the main earpiece so that it keeps that concave shape. But everything else I kept as the separate filament color parts and then just assembled. And honestly, this thing was going together so well. The pieces are very specifically shaped, so there's really no room for error, and it was just such a smooth process fitting all of these pieces together. The one part that I left unglued was her head onto the neck pole. That way you can swivel it and pose it in different directions. And here is the finished Judy Hopps model. This was such a fun print project and an absolutely phenomenal looking 3D print. Each of the individual pieces printed so well and assembled all together like this in the final model looks fantastic. I'm happy to say that overall, it's been a pretty positive few weeks of putting the Centauri Carbon 2 through its paces. But as with every 3D printer, it has its pros and cons. As I mentioned earlier, I did have my reservations about the design of this machine, particularly in relation to the shroud lid situation. Thankfully, it doesn't seem to pose a real problem when it comes to maintaining chamber heat. With a 105 degrees Celsius bed, the chamber consistently read a temperature of at least 45 degrees Celsius. The warmest I ever saw was 51 degrees Celsius, but I have a feeling that was probably when the bed was closer to wherever the chamber thermometer probe is. Even with the bed nearly at the bottom of the enclosure, it would still be hovering at about 45 degrees Celsius. That tends to be a warm enough environment for materials like ABS, but some heavier duty engineering filaments may require a warmer temperature for the best printing results, especially depending on the type of print it is. The large upper shroud or lid is of course due to the design of the canvas and how the PTFE tubes attach and run from that to the hot end. This does end up making it quite a tall 3D printer. That's not really a pro or a con, just something to keep in mind in terms of setup and space requirements. Even if you chose to not use the shroud and put it on top, the PTFE tubes do run fairly close to the inside, so you would still need that height clearance. I do, however, really like the design of the canvas and the spool holders on the side of the printer. It is very easy to load and unload filament, truly enjoyable to use. With all of the spool holders attached to the side of the machine, it also means it's a single solid unit that's only taking up this much desk space. Technically, you could even have the holders hanging off of a table if you were really pressed for space. Also, the new side panels on the CC2 are so much nicer and stronger than the original Centauri Carbon. The originals were like thin metal sheets that didn't did not feel like they supported the spool holder well, but these panels are nice and rigid. The spool holders all feel like they're attached very securely, and I would imagine the nicer side panels are probably also doing a better job at retaining the heat within the chamber. The rubber pads on the spool holder are really my only complaint. Initially they were fine, but the more I've used it, it's gotten worse, to the point that pretty much any time I remove a spool from one of the holders, at least one of the pads fall off. They are easy to reattach, but it's super annoying and just shouldn't be happening. It's doing it on all of the spool holders as well, so it's not like I just had one on my machine that was damaged. They all seem to be becoming loose over time and constantly fall off when changing spools. They're also kind of important, so it's not like I want to remove all of them. The rubber is what creates some traction for the spools so they don't slip off during use. I'm not exactly sure what the solution would be to this, possibly using a less flexible rubber so that the pads wouldn't be able to flex out of place and fall off. Maybe I will end up trying to glue mine in place so that I don't have to deal with them falling off all of the time. Who knows? But yeah, definitely something that needs to be improved and fixed. Since we're on the topic of the multi-spool system, let's talk about the canvas itself. This is technically an open source RFID system, which means other filament brands could adopt it to be compatible with their filaments, which is incredible. Automatic filament reading is obviously more of a luxury rather than a necessity, but it is a convenient feature and can be quite time-saving. Right now, the firmware on the CC2 is a little clunky, or at the very least, I think there could be some improvements made. Right now, when you use the RFID reading, you first tap the spool to the reader on the canvas module, and that then prompts you on the machine to select which slot that filament is installed on. I would argue that the majority of people are probably tapping the spool on the reader and then installing the filament onto one of the spool holders. So if the software could recognize that there was just a spool scanned and then filament was inserted into slot 3, say, and put those 2 points of information together without additional input from you on the machine, that would be very convenient. Same kind of thing for when you're installing any spool into the machine. If the window for filament settings could automatically pop up once the filament has been installed on a particular slot, that would be great. So let's say you put some black PLA into slot 1. The machine could automatically pull up the settings menu for slot 1 when it recognizes that new filament has been inserted. And then from there, you could input the type and color of filament from that menu. Right now, it feels a bit cumbersome to have to go through multiple menus to get to what you need and then have to input more information yourself, especially because right now it also doesn't automatically reset the information when it knows filament has been removed from a slot. So let's say I had blue PLA installed on slot 1 and then removed it. The machine knows that there's now not any filament installed in slot 1, but if I install a different spool, the machine treats it as if I just replaced the same roll of filament. Personally, I think it would be better if the printer would automatically reset the information when it knows filament has been removed. That way it would basically naturally remind you to make sure all of the filament information is correct if there isn't any information for a particular slot. Because even I, a couple of times, forgot to go in and make those changes since it recognized there was a new roll of filament and kept all of the same settings. I didn't think about the fact that I had put black in a filament slot where it said it was blue. So just little firmware tweaks like that to make the user experience a little better. I know the main draw for the Canvas system is going to be the ability to multicolor print, but it also has the ability to auto refill filaments, which is something I constantly find myself using. Not needing to manually replace filaments when one spool runs out is a huge help, especially if you're using the printer in a business sense. It's also great for being able to use up every inch of filament on a roll. And also, just as a little side note, I had about every brand of filament that I own set up on this thing at one point, and all of the different spools fit on the holders no problem, so if anyone was curious about that, there you have it. Overall, the print quality is very nice. I think the majority of people would be very happy with how these prints turned out. However, I think the print quality could be even better if the default profiles were dialed in a little more. Now, I can't ever truly test a 3D printer out anymore from the perspective of a beginner, but I try to make a point to intervene as little as possible and use default settings, at least in the beginning. That way I can see how successful someone could be if they were just just starting out and didn't have years of experience and knowledge. In my opinion, the default slicing profiles that are available for the Centauri Carbon 2 have some weird setting choices that I believe could ultimately affect the print quality and the success someone might have with this printer, which is, you know, not exactly something you want to have happening. Thankfully, these are things that can be very easily changed in the future, either by the user or as the slicing default. By the time you're watching this video, these changes could have already been made, who knows? The biggest one for me that I notice is that literally all of the default profiles have the support separation gap set to 0.08 millimeters, which effectively means those supports are going to be welded onto your parts. And that isn't exactly going to make for a very good looking print. Typically, you will have this value set to a distance equal to your layer height. So if you're using a 0.2 millimeter layer height, your support separation gap is also 0.2 millimeters. Also, for some reason, anything that could be set to honeycomb as a default was set to honeycomb as a default. I didn't even know honeycomb was an option for half of these settings until I ended up seeing this with my own eyes. This is maybe more of a personal preference thing rather than an actual problem that will lead to weird print artifacts or whatever, but there is a chance, at least for the infill, that it could lead to longer print times and less structurally sound parts depending on how it's being used. I like the settings that I use and I like how my prints turn out when I use them, so it'll take a lot to convince me to change my ways. I'd also say the default filament profiles all run too cold, at least in my experience. That's thankfully one of the easiest changes that you can make as a user, so I'm not that mad about it. It's not like I was needing to run in-depth tuning tests to get good results with this printer. It's just, again, one of those things that speaks to the ease of use, especially for a beginner that doesn't necessarily have the knowledge of what filament temperatures to use, or that their prints aren't turning out right because the temperatures are too low. The most problematic would have been the ABS. I believe the default had the bed temp set at 85 or 90 degrees. I ended up using 105 degrees Celsius. Clearly quite a bit of difference there. I wouldn't normally go above 100 degrees, but I thought that the printer could probably use those extra 5 degrees to help keep the chamber warmer, since it is the bed that is passively heating the enclosure. So assuming that the ABS would have stayed stuck to the bed at all at 90 degrees Celsius, the chamber temperature probably would have been way too low, or at least on the edge of being warm enough for a successful and strong print. Something that I always like to touch on in these videos is parts availability. It was one of my largest concerns and continuous problem with the original Centauri Carbon, and with this printer not technically being out while I'm recording this, I can't speak to exactly what the parts availability is going to be like. So this is more of a note to Elegoo to please make the various replacement parts for your machines more readily available. And I hope that the parts availability improves for the Centauri Carbon 2. With all of that being said, overall, I still had a very positive experience working with the Centauri Carbon 2. It's a very capable machine that produced some great looking prints for me. It's a printer that I'm sure is going to tick a lot of boxes for people, and I hope that at least some of the possible improvements and changes that I mentioned can be implemented to make this printer even better for everyone. If you'd like to find out even more information about the Elegoo Centauri Carbon 2, there will be links in the description box. But that is everything. Thank you so much for watching, and I will see you in my next video.